Physics Blender. I love 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 Physics Blender. Subscribe for more videos.
Question 6 for extended candidates only, because here we are talking about magnifying glass when we are using converging lens as a magnifying glass. Which ray diagram showing the rays passing through the converging lens? So here is asking you about which type of lens. How do you know the lens is converging or diverging? This one is diverging, so we will exclude A and C. So you have to choose between B and D. Okay? In this case, the image will be formed where the refracted rays intersect. So this is real. Virtual image is formed by extension of rays. So you have to extend these two rays, the one passing through the optical center undeviated, you can extend, okay, and here the one parallel to the principal axis will converge. Its extension also should be drawn where they intersect. This is where the image is formed. Okay, so in this case you have magnified or what we call it enlarged image. It's upright and it's virtual. So this is the case of magnifying glass. Again, guys, it's for extended candidates only. Question 7 here is challenging question because we have here ray box which gives you a very narrow beam of light ray, and we have position 1, position 2, and we have position 3. Which type of lens is used at each position? I will try to explain it in a very simple way. You can extend the light rays and you can see if the light rays are converging or diverging. Okay, so the first light ray at position 1, it could continue in this direction but it converge. This one, it could continue in a straight line, but what happens? Converging. So position 1, it's converging. Is it clear? We will continue here at position 2. It will continue also in a straight line. It could continue in a straight line, but it's converging. Here, it could continue in a straight line, but also it's converging. So also in position 2, it's converging. Let's check the last one, position 3. Here it could continue in a straight line, but what happens? It's not converging. Can you see the difference between the two cases? Here it could continue in a straight line, but what happens? It's not converging, it's diverging. Is it clear? So in position 3, it's diverging. Okay guys, so here this is question 7, which is challenging. So the answer of question 7 is B. We have converging, converging, diverging. It's challenging question. Let's move to question 7. Question 8. Question 8, we have a digital camera uses lens to produce diminished, smaller image on a light sensor, which row showing the correct type of lens and the nature of the image. While we were discussing converging lenses, we discussed the case of a camera, and we said the image produced by the camera should be diminished for sure and can be received on a screen, so it's real, and diminished real, and it's also smaller in size, as we said. So it's real, it's diminished, and it's inverted. Okay, so for sure we are using converging lens to obtain the properties I mentioned here. The image should be real, inverted, and diminished, so you have to use converging lens. You have to use converging lens. Question number 9. Question 9, here we have a diagram showing rays of light which is in the space labeled X. Also we have here region, and it contains a lens but unknown. We have no idea, or maybe a plane mirror or a rectangular glass block or a prism or whatever. So what is in the space? Since the parallel rays here are diverging, so what we have in the space, we have here diverging lens. It's very simple. Question 10. Question 10 here, the ray diagram showing two rays from a point on an object, and we have here a diverging concave lens. What are the properties of the image produced? As I told you earlier, we have two standard rays, one which is passing through the optical center undeviated, and the other one parallel to the principal axis, so it will be refracted and diverge, but its extension will lead you here to the focus. So this is F. Okay? Where the two rays intersect, this is where you can find the location of the image. So the image is here. Okay? How can you describe the image? The image is virtual because we have extension of rays. The image is diminished. The image is upright, not inverted. Again, whatever the location of the object, you will obtain the same properties of the image. Okay, so this will not affect the properties of the image. So question 10 here, the answer is D. The image is virtual and diminished. Is it clear? Okay, question number 11. We have an object which is viewed through a diverging lens. What is the correct description of the image? And here we have no idea about the location of the object, but we know that the properties of the image will not be affected. The image will be always virtual, upright, and diminished. So the answer of question 11 is D. Okay, the last question we have, question 12. We have an object and we have the principal focus is shown, and you have to find the position of the image. Let's draw. Okay, the object here, the first ray parallel to the principal axis will diverge, and its extension will pass through the focus. Okay? The other one passing through the optical center. The other one passing through the optical center undeviated. Where they intersect, you can find the location of the image. So the answer is B. Let's again one more time describe the properties of this image formed by diverging lens. Whatever the location of the object, you will obtain the same properties. Or let's say it in another way. The location of the object will not affect the properties of the image. So you will find the image. So the image will be virtual, upright, and diminished.